This is Physics 2212 Lab 1 going over charge tapes. Now, in this lab, we'll be observing interactions between two pieces of clear tape with both each other and other objects, and one of the things we'll be doing is determining the excess charge on one piece of this charge clear tape. Now, preview of the results, we get the charge of an individual tape is going to be about 1.4 times 10 to the negative 8 coulombs, with about a deficiency of 8.75 times 10 to the 10th electrons. Now, two concepts we need to get out of the way. The gravitational force, where F is equal to negative mg, where g is a gravitational constant equal to 9.8 meters per second squared. And then Coulomb's law for electric force, where F is equal to k times two charges divided by the distance squared. And k here is going to be 9 times 10 to the ninth Newton meter squared per Coulomb squared. Now, some assumptions we're going to make. First, air resistance is just going to be ignored. The long tape is going to be treated as a point charge with all the charge concentrated at the center of it, and then each U-tape has about the same charge, which is going to be evenly distributed along the length. And sources of potential error will be inaccurate measurements from just eyeballing with a ruler, and then inconsistency in the replication of the procedure. Now results, the interactions between two U-tapes saw both of them repelling, meaning they have similar charges, and a U-tape and a hand or pin attracted, meaning they have opposite charges. And since we know that the pin is going to be negatively charged because rubbing a clear plastic object onto something like cotton will negatively charge the thing, we know that the pin has to be negative and the U-tape is going to have to be positive. And then we saw the U-tape and a suspended U-tape are going to repel likewise, and that was a distance of about 0.03 meters apart. And from all this, we can gather that the U-tape is positively charged. Now, the length of one tape was about 0.2 meters, and its mass is about 0.0002 kilograms, given that clear tape is about 1 gram per meter. And then the distance between the tapes, like I said earlier, was 0.03 meters. Now, plugging these numbers into the gravitational force formula gives about negative 0.00196 newtons in the y direction for the gravitational force. And going on to the electric force, since we assume the charges of the tapes to be equal, we can get Q1 is equal to Q2 in this formula in the top right. And we know that we're in a state of equilibrium because the top tape is floating, that the electric force is going to have to equal the opposite of the gravitational force. So the gravitational force is negative mg, so the electric force is just mg. And plugging all that in to our electric force formula and solving for q, since we get kq squared over d squared, we can get the U-tape's charge to be about 1.4 times 10 to the negative 8th coulombs. And then we can solve for the number of atoms, which is the surface area divided by the area of an atom. So we get about 3.8 times 10 to the 17th atoms. And the number of deficient electrons is going to be equal to the charge observed divided by the magnitude of the charge of an electron. So we get about 8.75 times 10 to the 10th deficient electrons. And the ratio of the two is going to be one deficient electron for every about 4 million-ish atoms. Now putting that into GlowScript, these are just some constants setting up at the beginning, like the gravitational constant of 9.8 and the charge of an electron, and then the measurements of the tape as well as the area of an atom. And then the gravitational force, where we get a variable called mass grav is equal to gravitational constant times the tape's mass, and then have that in the negative y direction. And then electric force, because we said it's in equilibrium, it's equal to the opposite of the gravitational force. And then we can solve for charge knowing this mass grav variable, which is just the electric force. And then solving for the number of deficient electrons is just the charge divided by the magnitude of an electron's charge. Number of atoms is going to be the tape's surface area divided by the area of an atom. And then the ratio is just going to be the ratio of the two. And this is the visualization of the model, where red is going to be the electric force pointing upwards, because the blue balls are going to be the point charges representing the tape, and because they're the same charge, the red line is going to be pointing away from the other blue sphere, and meanwhile the green represents the gravitational force pointing downwards. Now, what if the electrons had a positive charge and the protons had a negative charge, and how would the observations change? Now, if and this would just change the direction of the electric field pointing into the tape, since the tape would be positive in how we did it in the lab, it would become negative, in which case the electric field lines point into the negative, so we end up getting that change, but the visual observations should remain constant because the two tapes are still the same charge, like similar charges, with the pin being the opposite charge. So the pin is positive, but the tape is negative. So the visual aspect remains similar. And then why is it important to handle the charge tapes with as little as possible? This is just to limit the transfer of electrons and charges, and the tape would end up becoming more negative if something like a negatively charged pin were to come into contact with it, changing the charge. Thank you.